Welcome to section 5.2, day 1, verifying trig identities. Today we're going to verify trig identities by using algebraic proofs. To verify a trig identity means you prove both sides of the equation are true for all values for which both sides are defined. You do this by transforming one side of the identity into the expression on the other side through a sequence of intermediate expressions that are equivalent. It is usually the easiest to work with the most complicated side. This is an algebraic proof, so you must justify each step. Another thing is we are not allowed to do anything across the equal sign when we do these proofs. You must only work with one side. You cannot use any rules of equality for this. You must only work on one side at a time. So how do we do one of these? We have tangent squared x plus 1, or 1 minus sine squared x equals secant to the fourth power of x. Looking at the equation we have here, the left side definitely looks more complicated, so we want to turn the left side into the right side. And we look at all the different identities we already know, because we can use those to help prove that one side equals the other. We want to get things in terms of secant, because that's what the right side has in it, so we want to turn things on the left side into secants if possible. One of the things we should be able to see right away is that we have a tangent squared x, and this is one of our Pythagorean identities, and tangent squared x is the same as secant squared x minus 1. The first thing I'm going to do is change tangent squared into secant squared x minus 1. And when I do this, I have used one of my Pythagorean identities. Like I said, we're only going to work on the left side. I'm going to abbreviate to save time. This is a Pythagorean identity we just used. Then we're going to simplify the top. Here we have secant squared x minus 1 in parentheses plus 1. If I drop the parentheses and add the negative 1 and the 1, all I have left is secant squared. All over 1 minus sine squared x. We just simplified here, and this is my justification. This happens quite often with these, where we just have to simplify something. Now we have 1 minus sine squared x in our denominator. We want to get that in terms of something that would change into secant. Well, we can use a Pythagorean identity again, because 1 minus sine squared x is the same as cosine squared x. So we can switch that out and make it into a cosine. So we have secant squared x over cosine squared x. And here we used a Pythagorean identity. Again, our goal is to get the secant to the fourth power x. So I'm going to see if I can change my cosine into something that I can use. I'm going to rewrite this so it looks a little different. This is multiplied by 1 over cosine squared x. This is just a rewrite. It's just to demonstrate, to show what's happening. And 1 over cosine squared is the same as secant because they're reciprocals. So we get this. And here I used a reciprocal identity. And then from here we multiply secant squared times secant squared, and we get that secant to the fourth power. And here I just simplified again. And so we've shown now that secant to the fourth x is equal secant to the fourth x. So I can do with this, I'm going to put this back in here like this. And therefore I can say the following. I can say that tangent squared x plus 1 over 1 minus sine squared x equals secant to the fourth x. We have proved it. We put this little box there and it shows our proof is done. So this is how we verify trig identity. We go through step by step, transform one side into the other, and that is how we do our proof, and then explain what you're doing in each step. If you use the identities, if you're factoring, if you're simplifying, we state what we're doing. Here we have 2 minus cosine squared x equals 1 plus sine squared x. This one you can choose either side to work with. They're both as complicated as the other. I'm going to choose to work on the left side. So I want to transform this into 1 plus sine squared. So the first thing I look at is there anything I can switch into sine squareds? And I have a cosine squared, so we can use our Pythagorean identity. Cosine squared is the same as 1 minus sine squared. So I've used a Pythagorean identity again. You'll see we're going to use these same identities over and over and over when we do this. Okay, we use a Pythagorean identity. Then we're going to simplify the left side here. We have 2 minus 1, which is 1. And then we have minus minus. This is plus sine squared x. We simplify right here. This is probably about the easiest you can get. They do have, some of these are just as simple. We have 1 plus sine squared equals 1 plus sine squared. So I'm going to put my little statement in here. So 1 plus sine squared x does equal 1 plus sine squared x. Therefore, the little 3 dots means 2 minus cosine squared x equals 1 plus sine squared x. Not the greatest writing there. And my proof is done. That's like the easiest one you could probably see, and I think there's 1 or 2 like this on your homework where you just have to do 1 or 2 steps to prove it. Here it says verify trig identity by combining fractions. So the right side of this one is definitely more complicated than the left. And we want to get this into one term, so we want to combine our fractions. And so we have to get common denominator. So we're going to multiply the first one by 1 minus cosine x. So we have 1 minus cosine x, sine x in the top, all over 1 minus cosine x, 1 plus cosine x. And we have minus. We're going to multiply the second one by 1 plus cosine x. This is times sine x, all over 1 plus cosine x. And 1 minus sine x, or 1 minus cosine x, sorry. Okay, and here we're getting a common denominator, and that's actually what I'm going to say. I'm going to say common denominator off from the side here, because that's the whole reason why I just did this. So now we're going to simplify. We have sine of x minus sine x cosine x. And since we're going to give a common denominator, I'm going to use this. So we're going to take minus, then 1 times sine x, so minus sine x. Minus cosine x sine x, so minus. I'm going to use the same order as I did the first time, so sine x cosine x. All over, and when you multiply these together, you get 1 minus cosine squared x. So here we have simplified. Now we go through this and we simplify our numerator. And you'll see some things are going to cancel out. These are going to cancel out. And we have sine x cosine x twice. So we have negative 2 sine x cosine x all over 1 minus cosine squared x. All right, from here, this is just another simplify, by the way. From here, I need to do something with my denominator. I have 1 minus cosine squared x, and that is the same as sine squared x. So I'm going to change this out to sine squared x. This I use a Pythagorean identity again. From here, I'm going to run out of room here in a minute, but we'll see if I can squeeze it all on here or not. Okay, so now we're going to move up and we're going to work on this a little bit more. We're going to spread this thing out to see what we can do with the sine squareds, and the cosine. I'm just going to rewrite this so you can see what happens. We have sine x cosine x in the numerator. I'm going to break sine x squared, or sine squared x, into sine x sine x. Because when I do this, what ends up happening is our sine x's over sine x cancels out, and I'll look at cosine over sine. This is negative 2 cotangent x. This is a quotient identity. That's what we're left with, which is what we wanted to get. We got it back to -2 cotangent x. Since -2 cotangent x equals -2 cotangent x, therefore, -2 cotangent x equals that beginning part, sine of x, 1 plus cosine x, minus sine of x, 1 minus cosine x. And I have completed my proof. I've completed my verification. Like I said earlier, we're going to start working with the harder side first to try to simplify it to the less complicated side. Right here it says that verify that sine of x over secant x minus 1 equals cotangent x plus cosine x plus cotangent x. I'm going to work on the left side. I want to get rid of this fraction. And I want to use something that I know can use an identity with. So I am going to change and the denominator here. I want to make it into secant squared x so I can use a Pythagorean identity. So I'm going to multiply the top and bottom of this fraction by the conjugate of secant x minus 1. So I'm going to try and multiply the top and bottom. I'm going to multiply. So I'll multiply the top and bottom by secant x plus 1. Now I have sine x secant x plus 1 over, when you multiply these together, you get secant squared x minus 1. And what I just did is I used my conjugate. So I'm going to multiply by conjugate. I'm going to abbreviate here, just to save me some room on the slide. I am then going to look at my denominator, because I have a secant squared minus 1, and I can use a Pythagorean identity for this. So I have sine x. And the order you do this doesn't matter. I could multiply the sine x in first. I just chose to do the secant squared x minus 1 first. So we just use a Pythagorean identity. Now I'm going to multiply the numerator together. We have sine x secant x plus sine x all over tangent squared x. And all I did was simplify. I'm then going to rewrite my secant as 1 over cosine, because I want to keep simplifying this down as much as I can. This is all over tangent squared x still. And what I just used is a reciprocal identity. When I multiply those together, you get sine of x over cosine x. Sine of x over cosine x is tangent x. So now I have tangent x plus sine x all over tangent squared x. And what I did is when I multiply those together, I got sine x over cosine x, and I used my quotient to get the tangent. I just used my quotient identity. I gotta go back up to the top here. I'm now going to break my fraction up into 2 fractions. So I have a plus sign in the numerator, I can do that for my numerator. So I have this is equal to tangent x over tangent squared x plus sine of x over tangent squared x. And all I did was split my fraction. And I can simplify the first fraction to be tangent x over tangent squared x. This is 1 over tangent x. And we simplified. There are a couple of different ways to look at some of these things that we're going to be doing next. We have sine of x over tangent squared x. You could rewrite this as sine of x times cotangent squared x because reciprocal, which is probably the easiest way to do this. I'm going to make 1 over tangent x is cotangent x. And this becomes sine x times cotangent squared x. This is reciprocal identities. Notice we want to have cotangent in our answer. That is one of the reasons why I did this. So our first term is cotangent x. We have that. We need to modify the second term to match cosine x, cotangent x. So I'll leave the first term alone. And I'm going to break up cotangent squared into cotangent x. Cotangent x. We're just simplifying there. I'm going to change one of my cotangents by using a reciprocal identity. And cotangent is the same as cosine x over sine x. It's still times cotangent x. And I am running out of room. This was a quotient identity that I just used. Like I said, I'm running out of room. Okay, quotient identity was just used. And now we're going to simplify that by multiplying together. This is cotangent x. The signs cancel out, leaving cosine x, cotangent x. And we just simplified. Again, I'm running out of room. It's getting hard to write in here. So we've just got the left side equal to the right side. Since we have the left side equal to the right side, therefore, what we started with, sine of x over secant x minus 1 does equal cotangent x plus cosine x, cotangent x. And that's, this is a long one. It's the longest you'll see, actually. It can get complicated. Just keep plugging along. That is all for section 5.2, day 1. Today we are doing proofs with trig identities to verify trig identities. Thank you for watching and have a nice day.